Today's operator signal is this: AI agents need service catalogs, not just tool lists. Most teams still describe an agent as a name, an endpoint, a few tools, and a model. That is already too shallow. Recent standards drafts and framework releases point to a more practical layer. Agents need to advertise how they execute, what model routes they use, what systems they can touch, and what evidence they return. Start with a July 6th IETF draft on registration and discovery. For multi-model agents, the draft makes a simple point. Production agents are no longer static. A single agent may route routine work to a cheap, fast model, complex reasoning to a stronger model, and degraded traffic to a backup model when capacity is tight. Outside systems still see one endpoint, but the agent's latency, cost, quality, and capability can change depending on internal routing. That creates an operating problem. If your catalog says this agent has one stable capability profile, downstream workflows may make bad choices. The draft proposes model profiles, model ID, type, version, capability, latency, context length, cost, availability, and supported skills. It also describes updates when a model is added, removed, changed, or degraded. The operator takeaway: if you are running multi-model agents, the routing policy is part of the product. Do not hide it only inside application code. Surface enough metadata for orchestration, compliance, service level expectations, and cost controls. Second, another July 6th IETF draft looks at AI agents interacting with IoT devices through SDF and CoAP. This is where agent governance stops being abstract. The draft says CoAP lacks a mechanism for a client to declare that it is an AI agent or carry an authenticated agent identity. It also says device descriptions may be machine readable, but still too terse for language models, which can cause agents to misinterpret device capabilities. In physical environments, that error can move from wasted API calls to safety hazards. That matters for factories, facilities, fleets, healthcare devices, smart buildings, and field operations. When an agent can actuate a device, the device needs to know whether the caller is an agent, what identity and policy attached to that agent, and whether the description is clear enough for autonomous use. Third, a July 6th IRTF draft on network and system considerations for AI services shows the infrastructure side. AI inference is no longer only a high-performance data center workload. The draft discusses cloud servers, edge devices, commodity machines, small hardware, and distributed AI services. For builders, this means placement is becoming a design decision: which requests run locally at the edge or in the cloud. What happens when latency, bandwidth, cost, privacy, or hardware availability changes? Agents need routing policies that understand the environment, not just the prompt. Fourth, the Model Context Protocol Server project shipped a July 4th release updating the everything file system, sequential thinking, and memory servers. This is not a flashy model launch. It is more important than it looks. MCP servers are becoming connective tissue between agents and real systems. That means they need normal software discipline, versioning, dependency tracking, change review, and rollout controls. Fifth, LangChain's July 5th releases show provider integration details maturing. The Open Router integration added support for custom default headers and refreshed model profile data. The Mistral integration surfaced citation metadata from chat responses and also refreshed model profile data. These are small release note items, but they are exactly the kind of metadata operators need: which provider, which model profile, what evidence came back, and what trace information should follow the run. Put the pattern together. The next agent stack is less about having one clever agent and more about maintaining an agent service catalog. That catalog should answer 6 questions. What models can this agent route to? What are the cost, latency, context, and quality expectations? What systems and devices can it call? What identity does it present? What versioned MCP or tool servers does it depend on? What proof, citations, traces, and lifecycle events does it produce? The playbook is clear. Inventory every agent as a production service. Add model route metadata, not just a model name. Track degraded modes and fallback behavior. Make tool and MCP server versions visible. Treat IoT and physical actions as policy gated. Log provider, metadata, citations, and traces, and require owners for cost, reliability, security, and rollback. The takeaway: agents will not become dependable because they can call more tools. They become dependable when other systems can discover what they are, what they might do, what they cost, and how to prove what happened.